challenges like, for instance, if you want to deploy 10,000 Bluetooth products under very bespoke applications, how do you do that? You pair every single one of them? No. You come up with a software strategy where you can work with the business top down and do it thoughtfully.
Well, hi everyone. Welcome back to the OnTrack podcast. It's Judy Warner. We're delighted to have you back again for another interesting conversation. This week we have Ed Becze, who is the managing director and co-founder of Peg Madison, which is a really high-end, very capable design firm out of Canada. We're going to talk about thoughtful design and what you need to think about from the sort of 30,000 foot view and things you can do to avoid problems as you move through your design. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hello, Ed. Thanks so much for joining us today. I'm excited to have this conversation with you.
Hi, Judy. The pleasure's all mine. Thank you.
Well, before we get started, Ed, you'll do a better job than I did in the intro, but why don't you tell us a little bit about Peg Madison, the interesting name that it is, and then tell us a bit about your background on what Peg Madison does.
Sure. Well, we're a cerebral company, and Peg Madison, those of us who actually had to learn languages in high school, ours was, one of them was Latin. So Peg Madison is actually derived from the Latin pegmata, which means scaffolding. And it's an apt name for our company because we help build the foundation of your product foundation for other companies.
Ed, before we get started, why don't you tell us a little bit about Peg Madison and sort of the scope of knowledge and services that you offer?
Sure. So the team was assembled about 12 years ago now for as a high-end design center for a very large contract manufacturer. We were tasked to design a mobile phone, two-screen mobile phone, which we did from bottom up. Unfortunately, the business model didn't work for that. So we stayed on a much reduced team. As you can imagine, that mobile phone requires huge amounts of resources, but we kept the core team, and we offered design services for this large contract manufacturer. And we've actually launched products through that organization for big companies like Google. We've worked with very large audio OEMs. In fact, we still continue to do so today. We've done, our main specialty was in connected complex products, basically disruptive products in the industry, because at that time, connectivity or IoT was just starting to come into the mainstream. So that's where we kind of assembled the team and sunk our teeth into those roots. In 2016, we decided to divest. There was a push to eliminate the regional footprint, so we took the team and we started Peg Madison after that. So that's how we came into an existence. We're entering our 5th year now, closing our 5th year.
So when you say bottom up, you're talking chip design, firmware, hardware,
everything,
LED screens, the whole system.
Absolutely. So you nailed it. So we're kind of unique in the sense that we've worked with multiple projects in the past. We're constantly challenged with working with fresh silicon. So we have a very talented team that could, let's say, work when the documentation isn't quite up to the hardware yet. So there's that aspect. And then we, as a company, it's been touted, how many years experience we have and so on and so forth. But the best way to describe the value of our company is The majority of the team members in this organization have over 1,000 patents assigned to their names.
Wow, that's impressive.
Thank you.
So you're like the SEAL teams of like the engineering, systems engineering,
Yeah, the SEAL team. Yeah,
or Black Ops or something very talented and elite.
Um, we like to think of ourselves that way, and it really shines when clients run into some real brick walls where they've turned on, insurmountable projects for months, and then we end up fixing it in a weekend. So we have full. By the way, I do want to point out we have full product development capability under one roof. We have all the hardware development, mechanical, electrical, system level architecture, RF, but then we also have a full complement of very, very, very skilled, highly experienced software developers as well. So we can do everything from firmware right up to the cloud, and then fully vetted systems. That's where we shine. We focus on the ultra durable, ultra reliable systems.
Well, when we talked last week, Ed, I was so impressed by the scope of expertise you had. This seems like a rare thing to really understand, sort of soup to nuts on the whole, end to end. And what I wanted to talk to you about today is it's very practical, but a little philosophical, because I think from your perspective and your tenure in the industry, I think you are much more thoughtful in the design from your whatever you're working on upstream and downstream, and seeing what those implications are before it becomes a roadblock. So, when you take on something, a big project like that, like what do you see as sort of the foundation of overall good product development? And maybe you can touch on a little bit, where the board design comes into that, with our audience in mind.
Sure, absolutely. Every project. So we've launched projects that scaled into the tens of millions in a year. So and that's basically from PowerPoint concept right through to launch into production. And this is done numerous times. We've launched scores and scores of products like that. So we have a very good handle on what's critical. And every single time it rolls down to a firm understanding of your requirements. And I think your listeners, probably most of them would be in the startup mode or startup space. So I think they'd be wise to listen to help their management drive them on product requirements closure and understanding how that product is going to disrupt the next gadget.
Yeah, I think so too. But I would say a lot of our audience who might just be in the middle of, iterating an existing product or whatever in industrial controls, but the world changes year to year dramatically. So, coming from sort of the manufacturing space as you did for a while, I think, I've been sort of ranting about talk to your fabricators. And I think you share that with me, but I think you have a new kind of a fresh twist on what that means. So you talked about sort of the requirements and obviously the constraints, but then there's schedule, there's risk, there's supply
Right.
chain, and supply chain is especially problematic right now. So what do those engagements for you look like, and Peg Madison like when you sort of engage those suppliers and those pieces of the puzzle early? What does that engagement look like?
That's a great question, actually. So, it when we deal with large mature OEMs, uh, they have their own supply chain, they have their own network. So the job is very straightforward. Where we run into some challenges is these new startups.
Mm.
They have a lot less experience and a lot less manpower, uh, and very few people have that holistic, let's say, appreciation for what product development really is.
Yeah, you bet.
Right. So what we found is early engagement with all the key players is extremely critical. And that includes the supply chain. So it's not just your manufacturing partner, but it's also your supply chain. You need to have a clear handle on what sort of technologies are out there and what's the best technology for you. And I also caution some of the listeners to really understand your technologies. You wouldn't believe how many times I've seen clients pick the wrong RF protocol for what they want to do. They just, they've heard it, they read it in the paper, and then all of a sudden that becomes mainstream. And it's like, that may not necessarily work for you, right?
Mm.
So it's again, it all falls back to the requirements and that experienced understanding of the requirements. Sorry.
Yeah, that sounds good. And when it comes to risk, tell me what you mean. I think of supply chain risk, like end of life, but I know when you're working with highly reliable products, there's multiple ways that risk can be introduced. What do you mean when you talk about risk?
When we talk about risk, we're looking at there. So you got to remember, we look at everything from a business perspective as well. So there's two elements of risk in all the projects. There's the product management side where it's going to meet a certain requirement for the business, and then there's also the technical side, which the technical people deal with on the let's say on the product level basis. And when we talk about risk, I'll focus on more on the technical side. Um, so quite often, one encounters development of a particular product or some type of solution that has never been done before, or
Mm-hmm.
there's an element of uncertainty in what one particular product manager wants to do. So thoughtful understanding of the requirements will help very knowledgeable people understand what the technical risks are very early on. And then you build a thoughtful development strategy, not the plan, but the strategy on how to mitigate those risks. And you want to knock them out early on so that when you finally converge on a solution that your engineering staff is more or less convinced, because engineers by nature were conservative, but when there's when there's enough certainty that this is doable, then it becomes a matter of execution. So that's
Mm-hmm.
why we tend to focus very, very heavily on risk mitigation very early on. And it comes at the system level. It's not just the hardware side. We've done it before on the software as well. Like they've been I mean, challenges like, for instance, if you want to deploy 10,000 Bluetooth products under very bespoke applications, how do you do that? You pair every single one of them? No. You come up with a software strategy where you can work with the business top down and do it thoughtfully.
Yeah, I hear this theme. And it is thoughtful, right? It's being mindful up front. And we've talked about this before on the podcast. I wrote a blog many, many years ago on the Microwave Journal website that said it was a quote by John Wooden, the famous UCLA winning basketball coach, and he'd say, "Be quick, but don't hurry," right? And the blog title was like, "Slow down to hurry up." And it sounds counterintuitive, but right, how much when you're doing thoughtful design, Ed, like, do you agree that if you slow down a little, you can hurry up a lot?
Oh my goodness, absolutely, absolutely. And back early on in my career, I just have to tell you, early on in my career, we were all, eager to get products done. But
Yeah.
as you move throughout your career and you come towards the twilight of it, you learn to realize, let's walk down the hill. I think it's a little better, right?
Yeah. Yeah. Things are lost. Oh gosh, I can't remember the quote, but it's something is like we lose ground while we're trying to be expedient, right?
Absolutely.
But we end up losing ground because we ran down the hill, right? And then we tumbled and we ended up in a
Correct.
pile at the bottom of the hill and then had to go back up the hill. So,
Yeah.
it sounds good philosophically, but when you have managers breathing down your neck, it's not always easy. But I think sometimes it's a fight worth getting into. So when you're talking about startups, right? Everybody knows that everybody's eager to get a startup because they have a great idea. But why do so many end up failing?
That's an excellent question.
That's a loaded question, probably.
It is, and it's all. So what I just have to rewind here and just kind of highlight that this is based on observation. This is not my opinion. This is actually observation, and I've done this before. But most startups fail to put so the primary thing that we see is that they failed to put up all the upfront effort into the requirements generation stage. So what that means is that they tend to go forward with product development by demo. So they'll create a prototype, right? A functional prototype. They'll
Right.
turn, and then they'll present it to investors. They'll present it to focus groups, peers, take it to a trade show, and then they thoughtfully collect opinions. And you and I know opinions are everywhere, right? And
Yeah.
then, the product managers that really haven't put the effort into it, they'll tend to shift the requirements. So what that means is that the engineering staff, the guys that are developing the product, they have a very difficult time converging on an actual platform because every you could have pivotal changes or cascading effects as it runs through your product development. Seen this time and time again. In fact, the phone that I alluded to earlier on,
Mm-hmm. Mm-hmm.
believe it or not, that was we had the firm requirements, but there was a lot of let's say development by demo, and
I see.
in that as well. And that it's not unheard of to realize a 50% cost overrun from your engineering budget, right? And you'll double your timeline. So
Yeah.
then you have to understand what's the cascading effect of doing that. Your launch date, presumably won't change. So
Mm-hmm.
now what suffers? And 9 times out of 10, it's test and validation. So you can understand what will happen then.
Yeah. That's where the rubber meets the road, right?
Absolutely.
And you know, if you're an EE and you have to do some board design and maybe a little bit of software development, but you got your mechanical guys on one hand and your whatever, you may or may not have been involved in developing the test for that. Like, how do we prevent this sort of narrow, electronics are complex, right? So how do we keep from getting into those silos and staying stuck and not really looking at our left and our right when things are so complex?
So again, you've asked a very deep question. In fact, it's very apt because we're kind of dealing with this somewhat as of recent. One observation I do have to make is a key driving factor for success in any. Let's focus on electronics. A key driving factor is experience, right? And I know your background, and I know roughly what direction you guys are heading, and I think you guys are spot on. And I'll tell you why. A lot of industry in North America today is focused around if you're a large OEM, you're focused around that big wheel with the million little spokes, and you're just a little spoke in the wheel. You lose a spoke, you replace it, and the wheel still keeps spinning.
Right.
So by definition, that means you only have, if you're that one spoke, you only have a little visibility about the whole wheel and maybe just a couple of spokes beside you. You know what
Mm-hmm.
I'm getting at? So you don't have a holistic perspective, and again, I want your listeners to understand there's never an attack on capability. The fact that you've graduated engineering, you've demonstrated you're capable. Now you need to put a little bit of miles on your shoes, right, just to learn those lessons. And I'll tell you why. Um, when we design boards, our electronics engineers, highly experienced, and they've built up uh, a complete and very extensive knowledge base on rules of thumb, right? So
Right.
whether it's like the most complex ultra wideband radar system or a very simple chip down design for a Bluetooth module, they follow not similar, but they all follow design rules, and you can learn the rules by bumping your head and churning, or you can read the documentation that comes from the chipsets. But I can tell you right now, I've actually asked my engineers this before. What's in absence of design rules or people that you can lean on? How do you like how good is the documentation out there? And only 5%, and this is out of the whole staff, only 5% of the chipset vendors actually provide you with enough documentation so that you can effectively do a design. The rest of that stuff you got to either figure it out on your own, or something like what you guys are working on should be able to help you eventually, right? It's a big.
Right. We're creating a collaborative environment space where it could be shared across the sort of chasms.
Absolutely. But
Mm-hmm.
imagine if you could put it, sorry for deviating a little bit, but imagine if your CAD package actually builds that into it, right? I know it's a
Yeah.
tall ask, but I've seen, you wouldn't believe how many times I've seen designs roll across our desk where they're not working. The client needs like an incredible amount of help, and it was designed with freeware. And it's like, I can't do a design review on this because I don't know, what the integrity of what you've actually laid out was, right?
Yeah. Yeah.
So,
Yeah. There's a lot of hidden pitfalls in that. And we've heard that from really expert top level people. In fact, one guy worked for NXP and said, don't trust the data sheets. I'm like, okay, I don't know what to do with that. But he sort of unpacked this like, well, there's sort of some rules of thumb there, but because of liability, they have to take the worst case scenario,
yeah,
right, to protect their liability from a legal standpoint. But then there's where the rubber meets the road, and you kind of need a good applications engineer, or you need a good mentor at your side, and there are ways to where sometimes those rules can be broken, sort of like if this then that, right? If
yeah,
sort of where the ground plane is, or and so it's not a small problem, but it seems to be one that you're managing, and you're doing it with a lot of years of expertise, which is wonderful. It's like, how do we create more of this? And I think we just have to teach people where to look, right, sometimes, and where to get the information. So you talked about design rules, and I think we're both saying that. Which design rules do you actually need to follow?
correct.
Is the data that you have actually accurate? I did a podcast not too long ago, and it was IPC rules that you need to know, follow, and sometimes break.
Yes,
Because sometimes it's okay to break them, and it's okay to break them by the language of the standard itself, right? You can make an agreement, and
absolutely.
that can be documented, right? And so, that podcast was sort of about that, like knowing when you can break them.
Yeah.
So much about data sheets. So you said earlier about engaging vendors. We touched on it briefly, but this is an area near and dear to my heart because the message that myself and others haven't been able to get successfully. If we are at Altium Live in our user group and we said, how many people here have ever been to a board shop or an EMS shop? The numbers are staggeringly low, like
Okay.
10% maybe.
Hmm.
So in your mind, what do you mean when you say engage during the design process?
Early on in the during the design process.
Early on in the
Early on.
design process, yes.
Yeah, so that's absolutely critical. And this is why when we design products, our trajectory into market's actually quite short. Um, And this is assuming that we have the latitude to go to some of our approved vendor network. But clients can bring you their vendor network. You just have to
Yep.
understand. So in that situation, we would sit down and assess very early on what sort of capabilities do they have. Do they have, and for the product class that we're trying to develop, what sort of test equipment do they like? Do they have a test infrastructure? Do they have access to test equipment? Because I mean, that could get very expensive. Do they have a test development staff? Manufacturing test is critically important, and it's probably next to product validation. That's probably the second most overlooked, if not the first. The two, depending on which company.
Mm-hmm.
But
Yeah.
manufacturing test is absolutely critical. And again, rewind. You have to, as a designer, you are the design authority. You own that. So you have to work. You're going to have to build a relationship with this vendor and make sure that they hear you when you define, I want these tests done, or I want this. And then the second thing is early engagement with your vendor will help you. You could uh, get PPV benefits. You could get access to their vendor network that they've worked with before and they're
Mm-hmm.
comfortable
Mm-hmm.
with. Um, if you engage early on, you can, and this is not just at the electronics level. This could be at the box build level. You have to
Uh-huh.
you have to understand what sort of assembly capability do they have. Like, can they assemble electromechanical systems, or is that something that you'd want to do elsewhere and then integrate? Right? It builds
Right.
strategy on how one designs the product. Right? You can imagine. So imagine if you've got electronics boards and electromechanical assembly, some sort of complex housing, and you're going to want to integrate it at your contract manufacturer. Do you want to bring in gears and little switches and motors and stuff like that, have them assemble it, validate it, and test it so that, as before it's a sub-assembly and put it, or would you rather buy it from some other, bring it in and have them
Right.
put the four bolts in and integrate it or
Right.
whatever? You know what I mean? And you have to think about that. And then on the network side, everything, successful product development relies exclusively on your network, and that includes your supply chain and your vendor base as well. Like, I mean, a lot of these bigger companies that offer different families of chips, and everybody's got their own preferred vendor for Bluetooth modules, etc. So you'd be very wise to keep very close contact with these people, because not only are you going to have visibility on end of life issues or some of the any of these intrinsic details that might be important for your product, you can
Mm-hmm.
also be exposed to some interesting technologies that could supplement or augment your product, right?
Right.
Very low cost, which is critical, right?
Absolutely.
Now, that's not to say that I'm an advocate of feature creep, but when you can put something in for very low cost and it's low risk, why not put it in and add fidelity,
Yeah,
right?
absolutely. And you mentioned something earlier about, so you build it, you do your prototyping, your pre-production here in North America, now you're ready to scale.
Yeah,
And that gets messy. And think this sort of takes me back to what you were saying about the name, the scaffolding of Peg Madison. It sounds like you're saying is really architect this out, right? Kind of have a end-to-end blueprint of what you're doing
correct.
before you start putting screws in holes. Before you start building the house, have a blueprint, right?
Yeah.
And that gives you an idea of the scope of everything, right? So handoff. Let's talk about the offshore handoff
Well,
pitfalls there, and what different people offer, for that handoff, or if they have
if
those capabilities.
yeah, well, that's the big question. Is some of the local shops, and I'm just talking with the North American footprint. They can go
Right.
down. They'll go easily go down to Mexico. Some have reach into Asia Pacific, but it's rarer. But yeah,
Easy for you to say.
yeah, yeah. But that's one of the questions we would ask if we see a product that there's huge potential for this thing to scale up. Like, we'll get the let's say the pre-production and maybe a certain ramp volume of production done here in North America. And then, as you say, the handoff to Asia can become quite, it could become a little bit challenging.
Yeah.
Right.
And sometimes even take you back.
Yeah, yes,
I
yes.
mean, take you back in re-engineering part of your product. If Is that
Yeah,
true or not true?
it can be true. And in fact, one of the key things that you have to realize whenever you offshore something that contract manufacturers or these EMS providers, they operate under very, very, very thin margins, very thin.
Very thin, right?
So whenever they can leverage a little bit of cost savings, they'll do it, right? They will. And it's not unheard of when you transition over to Asia where parts would get swapped out. Components could get swapped out, and of course, this is assuming that you have a proper validation process for that.
Mm-hmm.
But I've seen it before where plastics were swapped out for something a little bit lower quality, and devices were falling off the walls because the plastics that were shot they weren't quite the right chemistry. So
Wow.
you have to be very careful when you're making that transition. So it's best to partner with a good manufacturer that is credible and can make that transition over for you, because it's a brand new MPI process as well, right? When you're cookie cut, even if it's a cookie cutting process, it's never that easy.
Nope.
Never.
Never, ever, ever. So, yeah. So let's talk about that sensitive area of price, right? Everybody wants a lower price. So say your system design, you do all that and then you hand it off to purchasing materials manager and they have to execute against budget constraints. Like, what about the tension there? And I know I'm like giving you big fat questions here, but you know, we had talked a little bit about leveraging the purchase price and the variance in those things and the total cost of ownership and all those things. How does all that come into play when it is time to do specifically that handoff?
Well, if so, the question actually is very loaded because
I know.
are we to assume that you're still retaining design authority for it, and somebody has to approve these. So there's a lot of things that one has to consider when they're moving products actually into production. You have to get all your terms and conditions done. You have to get all your contracts in place. You got to make sure that everything, the B2B interaction between the company and the product provider, like the manufacturer, is
Mm-hmm.
all laid out. The foundation is laid out. When products typically go in, you could potentially run into supply chain issues like what we're seeing right now. So
Oh,
then,
yeah.
then there's a huge urge or a massive motivation to try and swap out components. But again, that's entirely possible, but you have to follow the same level of rigor with that. And then you also have to consider the design. A lot of these products need to go through some form of regulatory and compliance,
Oh, you
and
bet.
and you still need to have clear line of sight on what are you impacting. And
Yeah.
at the very least, even if it's a permissible change, you still have to let them know. I mean,
Right.
we
Right.
we've seen it before where it was not a devious change whatsoever, and we were the design authority on a particular product, but we had no idea that the vendor decided to swap out these components, and then all of a sudden Industry Canada is starting to knock on our door like, what's going on here? Something's
Oh,
going on.
dear. Yeah.
So now
So
we
I think that's kind of what I'm talking about is sort of the blind spots or the tension between the people who might be taking off your design,
Mhm.
pricing it out, and the tension between the need to get the very best price, but not compromise that design authority, like
Yeah,
that tension, managing that tension.
it's a process. So it's not even it should nothing in product development should ever be attention. Everybody should always focus on the well-being of the customer or the company that's
Mm-hmm.
developing a product,
Yeah.
right?
Mm-hmm.
So there has to be an amenable path forward. And look, if you have to try and do a cost reduction for a business reason, then do it. But follow a process. Follow a process that will ensure that you're still delivering what you intended to deliver.
Yeah. I like that answer. Making it a process. So nothing like that happens where Canada, regulatory people come knocking at your door,
Oh,
right? Have the
absolutely.
process sort of protect you. Supply chain intelligence is obviously a massive, challenging thing to handle now. I mean, it's always a area that can be tricky, but particularly now. So, what are some issues that make it critical both now but always to have that intelligence and really know what's going on with your supply chain?
Well, yeah, I mean, assuming that you're during product development or after, right? During product development, you always want to keep your ear to the ground for the new technologies because it helps you build roadmaps for subsequent products if you can't intercept it on this one. But
Mm-hmm.
then where I like to so supply chain intelligence from my perspective is just having a broad enough vendor base where I could bring in any type of system or component to my clients so that we can effectively build a product very quickly with high reliability. And having that type of network, I think, is critically important, right? Just for the sake of expediency. But then you also have to maintain you have to know the right questions to ask. Like, we'll never design in a component. One of the first questions we ask that, when's this end of life? And you wouldn't believe how many times I've seen somebody come up here with a prototype. They've engineered the solution, and then they go out, okay, well, let's put it into manufacturing now. It's not a prototype anymore. Let's get somebody to quote on it. And before you know it, half the parts are obsolete. They're end of life,
Yeah.
and you can't
Yeah.
get them. So now where are you at? Right? You're 18 months
Yeah.
behind.
Yeah, which is obviously a huge, huge problem. And then when that happens, that's the part where I'm saying you'll end up in a lump at the bottom of the hill and have to go back to the top, right? And
Yeah.
so getting that stuff early, which sort of back to what you mentioned about Altium, we're pushing really, really hard to get that intelligence sort of inside of the design environment because when it's critical and
Yes.
that you'll get flagged right through things like our active bomb or integrating Octopart and pieces of IHS because that is so expensive and so painful.
Oh, but it's actually there's a subtle but distinct benefit there of putting it into your ECAD solution, and
Mm-hmm.
that's so. If we look back, I mean, the old dogs like me, we rely on experience to do that, so we know when to ask the right questions.
Right.
But somebody new or fairly new to the profession, um, and depending on the environment that they're in, they
Mm-hmm.
they simply can't instinctively focus on everything. So if you have
No.
something that kind of brings it up, and
Right.
it's a real thing there,
Saying hello,
yes, exactly.
warning.
That's
Yeah.
completely invaluable.
Yeah. That's what we're trying to give that sort of proactive approach. And I've talked to companies that have used this and they'll see a part on one product while they're in the middle of the design get flagged for end of life or obsolescence. And then it also reminds them, oh my gosh, that other product that's in production that's running also has that part. So it flagged them not only for the current design they were in, but like, uh-oh, you know.
Yep.
So I think it's helpful. It seems like a really good piece of intelligence to me.
Hmm. I think that's an
You,
understatement, but anyway.
yeah, yeah. And it's not like, yeah, I'm sure not all the, it may not be perfect yet, but we and other companies, are pushing hard for that intelligence because it's such a critical piece. Yeah, Lord help us, especially now.
Well, look, I'll put it in. Sorry to give you a little segue, but think back. I was around when the first mobile phones came out, right?
Yeah, me too. You're
And
telling on yourself. Me too.
exactly. And
The
I'm
brick phones.
well, yeah, but then after you got the flip phones, we won't mention the company, but then they had this very it's almost it was a ridiculous interface. But then I asked myself, how are we going to put web pages on a phone, and how are we going to interact with it? I didn't have the solution, but look, we're doing it right now. The solution wasn't easy to come to, but smart people can figure this stuff out.
Yep.
Similarly with electric vehicles, right? I never thought I'd ever see the day that up here in Canada, with such a harsh environment, we'd see electric vehicles. But you know what? It's happening. They're on the road all the time, and they're surviving. So it can be done. So let's. I think the path that you guys are on, you got to stick with it, and just understand that there's going to be some churn, but you'll get there. You will get there,
Yeah.
and it
Yeah.
will be very useful.
Well, and that's the thing. It's fun to work for a company, and I'm sure you're in the same environment where you're trying to solve really, really, really hard problems. If it was easy, everybody would have already done it.
That is the
These are
main point.
complex problems, right? But the world's changing every day. New things are becoming available. But when Amazon decided to make this giant chain of distribution, and that was an extremely seemingly impossible feat, that I could click on something on Amazon and have it sometimes to my door in the same day, and so, like you said, people do create technologies that just bust through all the barriers. And one of our executives here said something that kind of blew my mind. And he said, I think electronics and technology are really just in their infancy. And, like you, I've been around a while, and I'm like, no, it's like we're making science fiction things come true. But he's saying, oh no, with what we have available now, just wait. And I'm like, my goodness, he's probably right. That we'll look back at this as, and it's hard to imagine, but it's really the speed at which things go. Well, before I let you go, I'm going to ask you a not too hard question here, because I like torturing you, Ed. Let's talk about the cost of not designing thoughtfully or creating a blueprint and processes. What's the cost if you don't?
Wow, the costs are huge, right? So
And not just monetary costs,
no,
like
you're absolutely right. It's so um, not designed. So, and believe me, we see this all the time. Um, your time to market is extremely extended because you're going to have to redesign it. I've seen in the last 3 months 3 products that are impossible to manufacture. That there's a huge desire and there's a demand for it, but you just can't do it. You got to go through a complete reset. I've seen, you have to really consider the system as a whole, understand assembly costs. Imagine how, we've seen products actually come that take several hours up to days to assemble. And it's not a very, it's not like an appliance. It should be like a gadget. Why?
right.
Right. So then you have to. So the DFA and the DFM wasn't done. So now your assembly and your manufacturing costs are skyrocketing. Right. Your
Yep.
delivery, like your yield drops. And one of the things that I see all the time is where companies try and save a buck on tooling or a buck on this and a buck on that, and it ends up costing them $10 in the long run. Right.
Well, that's kind of what I was talking about, the tension between the spend of a purchasing agent is like, oh, I saved a buck. And I'm like, oh, no, you didn't, because that's going to hurt later.
And And everything has to be considered. Like you have to look at volumes, right? Like when we look at those, and we were once required to sit on the CREC OECN process for a very large product that was shipping for a very big name. And we're the design authority, and a lot of those changes, fractions of a penny made a big difference.
Oh, you bet.
Right? Now,
Yeah.
conversely, if you're on another end, like the opposite end of the spectrum, where you've got maybe 500 to 1,000 units a year, and you make a proposal, like for, let's say you want to move from a module to a chip down design because somebody gets a brilliant idea. Well,
Uh-huh.
there's the redesign costs, there's your validation costs, there's your regulatory, and then all your tooling, and then your adjustments of whatever. So that when you've got volumes of 1,000, 5,000, 10,000, you know, if you have a $10,000 spend, that translates to $1 a part, and that's easy to do when you come into manufacturing, or
Right.
we're talking,
Oh, very easy. Uh-huh.
right? So the economics of that, you're absolutely right. I understand your question now. The economics of change is not an easy question to answer. It again,
Mm-mm.
as rewind. It's completely thought. It has to be done thoughtfully, understanding this your entire
The
business model as a whole.
implications, not just this $1,
Correct.
right? Because what are the downstream implications that may end up costing you more? And that's the trick.
Absolutely. Absolutely. And in terms of design, right? Like, I mean, let's face it, everything that we do here right now, everything, like, I mean, there's a huge push to bring, data, don't compute it in the cloud, do it on the edge. So there's a huge
Mm-hmm.
push to improve, processing power, which drives heat, which drives costs on the system, which,
Right.
everybody wants a small form factor. So now, the more astute ones are considering chip down designs.
Mm.
There's big costs associated with this, and then
Yeah.
there's also regulatory, which a lot of people don't consider. And that's
Yeah.
one of the first questions when we actually do bring it up to our clients. And they ask, "Well, what's the estimate?" And you give them the cost. I'm like, "Are you kidding me?" Even for something like we ran into a project a year ago, which I advised the client very highly against. They wanted to build like a SIL 3 level industrial device, right?
Mm-hmm.
Integrity level 3. It's like one step below nuclear. And I like, do you understand really what the just the certification requirements are? Forget about
Yeah.
regulatory. Just how do we rationalize, like, just because you put a bunch of components together that are SIL 3 doesn't mean that the surrogate system gets approved just because it is and all the components are. No, you still have to go through the regulatory, and you still have to demonstrate your software and all the human interactions, and everything has to be considered right from scratch. So does it really make
Mm-hmm.
sense?
Mm-hmm.
So anyway, I'll
And then down to the very simple when you're doing IoT. Well, then there's the EMI, EMC, and that's not cheap to do that kind of deal, or, flight systems and FAA, and,
ooh,
if you're making a drone, whatever. You think it's not a big deal, until you drill down. And I think it's helpful, like you said, to do some homework. And I think there's also kind of, because we do have access to good building blocks right now, the smartphone really gave us so much access to things where, they're saying, gosh, a, a couple people in a dorm can, launch a startup, which is true. And it's exciting. And I've seen students do this and some really exciting stuff. But on the other side, it's like the blind spots will kill you, if you don't know what they are. So, tying up here, so of course, time to market, and yeah, and if you're doing an IoT and the competition's heavy, time to market can put you out of business. So it's
oh, yeah.
not just that.
Well, time to market, not just even the business, but your schedules. Like, think about it. Think how much marketing collateral like a large OEM
Good call. Yeah.
right, spends on the next flagship product, and they
Yeah.
have to have it
Or
ready.
paying for you to be at CES or
Exactly.
whatever. Yeah. Uh-huh.
Exactly. So it needs to be ready for this particular trade show. It needs to be
Right.
demonstrable by this trade show. And how often, believe me, I've spent half my career staying up at night trying to make sure that that actually happened. So,
Yeah. Yeah.
anyway,
Yeah, and and you mentioned test, right? So if you can't validate the thing and test it at the end, that's a big problem. You mentioned excessive manufacturing cost, and maybe not knowing that some of the processes.
um,
Like I used to get this all the time when I was in RF. They just because they could use the CAD tool and they might have a PhD in RF and
oh,
microwave theory, right? And they laid out a board, and I'm like looking at it, and I'm like, that stack code doesn't work.
mhm.
It can't be done, or too many lamination cycles, or and then spin that out into assembly, and it's like it can't be done, or it can be done, but did you really mean to spend that much money? So
Or it can
anyways.
be done, but your manufacturer can't do it. They don't have the capability to put those little
Right,
tiny, like
right.
01005s down,
Yeah, it could be
right?
done in the world, just not at your,
Exactly.
in the term of your approved vendors, which is a problem. So, well, I don't know that we discuss a lot of solutions here, but
No.
it's a very interesting conversation, and I really appreciate sort of your worldview and looking at the importance of seeing things end to end and really, really doing very thoughtful design and thinking at a systems level. So thanks so much for joining me today. I've really enjoyed our conversations over the last couple of weeks, Ed.
Thank you, Judy, as always.
And I want you to come back and let's do another one, and you can teach me and our audience all about test and validation, because I know that's another rabbit hole we could go down, and I know you know a lot about that.
Yeah, we can talk a little bit about that one.
Okay, well,
All
thanks
right.
again for joining us.
Thank
For
you
our
so much.
audience, thank you to our audience for joining us today. We hope you enjoyed this conversation between myself and Ed Becze of Peg Madison. I'm going to put some links in the show notes below. Make sure you go check out their website and take a look around, and we will look forward to seeing you next time. Until then, remember to stay healthy, stay safe, and always remember to stay on track.